My mission this morning was to come from a community water supply perspective and how the pine beetle may impact community water suppliers. So I want to talk about the extent of the problem, the risks, the impacts on quantity, quality, and timing, wildfire, and the management implications to water suppliers. It's a massive problem for a significant amount of the community water suppliers. There's some 3,500 community water suppliers in this province, and a significant number of those are going to be affected. So what are the risks? You've heard this, I think, starting with Rita's presentation. Issues, there's risks with regards to water quantity, there's risks with regards to water quality, and there are risks associated with the timing of runoff. What we typically look at when we're looking at impacts from the beetle on the watershed is to look at the distribution of the forest cover. If you look at this one, you can see that the 32% represents the stands in the forest that are greater than 70% pine, and then the 2s, the 3s, and the 2s are in the 40s to 50s, 50 to 60, etc. The salmon-colored, the 29%, indicates the amount of the watershed that's already been harvested. The 22% and the 10% in the blues indicate the non-pine types. You know, I use this as an example, and the reality, or maybe from what Bill has indicated, is that it may not be quite as bad in some of these stands because of understory, but the fact is, the story that's coming from this is that the hydrology of that watershed is changing. What we're dealing with regards to water quantity as a result of the change in forest cover as we lose forest cover to the mountain pine beetle and harvesting is that there will be more runoff, and it will be more quick. Will come off more quickly, and we will have higher flows more frequently. And we will get more frequent high flows simply because the frequency analysis actually it changes, and I'll show that in a moment. This is an example using real data from Whiteman Creek on the west side of Okanagan Lake. The blue dots are the peak flows for the period of record that goes back to about 1950. The blue line is just a fitted line through that, which indicates that the peak flow for a 1 in 50 year event is somewhere out about 18 cubic meters or 19 cubic meters per second. The intent of this is to illustrate how what was previously a 1 in 50 year event could become something down as frequently as a 1 in 10 to 1 in 15 year event. Now, the impact of that is that a 1 in 50 year event is a channel changing flow. And if you look at the channels in Whiteman Creek and in Shorts Creek, for example, which went through those flows that are about a 1 in 50 year event, the lower parts of those watersheds, the lower channels, they look something like somebody put a D7 in the channel. It scoured the channel out to a depth of anywhere from 60 to 80 centimeters deep for 3 to 5 meters wide, and just scoured that channel all the way down until it comes out on the fan, and then deposited that material on the fan. So a 1 in 50 year event, if that becomes more frequent to something like a 1 in 10 year event, we've got significant risks of changing the water quality, impacting water quality. Loss of natural barriers is a real problem in our watersheds, particularly with the movement of wildlife and cattle moving in and around streams where they didn't previously get into those areas, and as a result we see increased fecal coliform material, and which leads to increased water quality problems, increased risk of pathogens, increased operational costs related to sediment, related to debris from increased flows on a day-to-day basis for the water supplier, simply looking after his intake, and ultimately increased treatment costs. We look at an example of a stream where the watershed is in pretty good condition, and we see the water quality, other than some color, is generally pretty good. We look at another watershed where the flows are increasing as a result of a variety of issues in the upper watershed. We see the fact that the bed is mobile, and also that the sediment load is mobile as well. Timing is a real problem to water suppliers, particularly with those that have limited supply in storage. Earlier runoff may result in an earlier demand from storage. This can result in supply issues if we're drawing from our storage earlier, which can result in a requirement for increased storage, which again results in increased costs to the water suppliers. The final one, which will be dealt with in more detail tomorrow, is the whole issue of wildfire. I was out in the bush last week, up in the upper elevations on the plateau, walking through some of the stands, picked up some of the duff from the forest floor, and it just crushed into dust, and that was at the end of May. We have some really severe wildfire risks that could be facing us. Wildfire risk is a risk in all of our watersheds, particularly in the southern interior. In the Okanagan, and the work that Blackwell has done, he indicates that the fuel loads in our forests in the Okanagan are all high at this time, and that's before the beetle got into them. The fuel loads are going to increase as a result of the mountain pine beetle, but this is an opportunity to develop fire management and wildfire preparedness plans, which is something that all water suppliers should be doing, and there are opportunities to move forward with something like that. Just to show you something that can be done to reduce some of these risks, particularly in the interface area, here's an example of a stand that was in its natural condition, and the fuel loads and the amount of understory in there and dead material is extremely high. And then they brought in a crew and did a fuel reduction and a limbing, and the risk of fire in this stand is significantly reduced. This is a type of impact that can happen when you get a severe fire. This is just across the valley from the 2003 fire. The material, the soil in that picture is about 30 centimeters deep. It is the consistency of flour. There is no organic material left in it at all, and when the rain hits, that flows down into the creeks, and it will completely wipe out an intake for a water supplier. So in summary, the point that has been raised since the beginning, the first talk this morning, is the hydrology of our watersheds is changing. There will be more runoff. The water quality will decrease. The wildfire risks will increase. And the costs to deliver safe drinking water will increase. But the watersheds will recover, but that's going to take anywhere from 30 to 60 years until we get back. So that's the good news. There you go.